Hello, good afternoon, students. Good afternoon to all of you. Good afternoon, guys. Please inform your friends to join the class. Good afternoon, Soumya. Good afternoon, Sajana. Good afternoon to all of you guys. So from tomorrow, I think so there will be change in schedule. We'll let you know. Okay. I think so. From tomorrow, you guys are having test right in your schools. So prepare well for your unit test for your schools, guys. Hope for all the best. Okay. So we're gonna start the class in another few minutes. Please inform your friends to join the class. I'm just launching one technical poll. Just let me know that am I clearly audible and is the screen is visible to each and every one of you guys? Just let me know, students. Okay, I can see that most of you are replying. That is really nice. So don't worry, we will be not going too much fast in these few days. We will be going in a smaller pace only because you guys are having test in the school. So I'll be not teaching you today lots of things. Hema, regarding holidays, there will be classes. We'll be teaching you regarding unit tests. Okay, but we will let you know the timings. Okay, guys. Okay, please inform your friends to join the class, guys. Inform your friends to join the class, everyone. So we'll be starting a class in another 1 minute. Please inform all of you guys. I can see very less attendance. Yeah, Jagan, I know from tomorrow you guys are having unit tests. So from tomorrow, what will be happening is we will be letting you know. Don't worry, guys. We'll let you know. Okay. But there will be something happening. Okay, don't worry. There will be something happening. Might be today evening. You will get to know something is happening. We have decided for you all. Okay. So something will be happening and soon will be informed to you. So I won't be teaching lots of concept, guys, today. I just will be trying to give you conceptual understanding regarding whatever we have learned yesterday and few questions if we can try. Okay. Please inform your friends, every one of you guys. You too, like students. Good afternoon. Good afternoon to all of you guys. Okay. I can see most very less. The attendance is really very less, guys. This should not go actually. Okay. Yeah. Yeah. I know, Amit. I know, Amit. So you have exam from 3 to 4:40 p.m. only. So we'll let you know, Amit. Don't worry. Okay. After the class only, we'll let you know regarding this. Okay, guys. So let us start our class. I think so. Few students have joined. No problem. We're gonna start our class without wasting lots of time. Okay, so I'm just going to end this poll. I think so most of you are saying that I'm clearly audible and screen is also visible. That is really nice, guys. Okay, so we'll start our class. So today our class structure will go like this. Okay, so first of all, we'll start with for a few recall test questions. So we're gonna do few recall. I have two few smaller questions that is based on conceptual understanding whatever we have learned yesterday. Okay, guys. And then I'm gonna make you explain about Faraday's law of basics, right? Faraday law of basics. Again, I'm gonna make you understand. Today, only one topic I'm gonna teach you, that is direction of induced EMF. Very important topic, guys. This is one of the important topic. VIT, very important topic, right? So you can give start to this topic because lots of questions have been in. See, this direction of induced EMF is a type of topic which will be used in all questions. Okay, because in questions you need to find the direction, which direction the EMF is generating, right? You know the EMF is generating, but which direction? That is very mandatory to understand. And questions have been asked, and easy questions have been asked, guys. So please make yourself comfortable in this because this is something new you will be learning. Something new you will be learning you have not learned till now, or you have not utilized this format. Okay, and then we will do little bit chit chat in last regarding your what are the test syllabus of your unit test, and what are the what how we can basically generalize with respect to your unit test, a basic revision for you. Okay, so let us move ahead, guys. Let us move ahead with recall test. So this is our first question, guys. Can you please tell me the answer of this question? I'm gonna launch poll in front of you. Please tell me the answer of this question and say me the answer in yes or no. Please tell me the answer, guys. Everyone try to participate and let me know the answer, guys. I want your participation, everyone. Okay. Please try, guys. I want your participation. Okay. So good to see few of the students are participating. It is a easy question. You can easily try it out solving this question. It's not a very tough. So you can see in this question they ask me the Faraday first experiment showing that keep magnet close to a coil will induce current in the coil. Is this true or is this false? Very common question. Okay, I can see most of the students are saying true. You're wrong. Guys, you are wrong. It is not true. Who told that keeping a magnet in front of coil is going to produce electricity? No, guys, you have got a wrong idea then. Most of the swing, most of you are, yeah, flux should be varying. For EMF generation, Faraday have told that for EMF generation, if you want to generate EMF, there should be change in flux. That is a mandatory condition. Change in flux. So if you're gonna keep the magnet close to the coil, will be any change in flux? There will be no change in flux if you're gonna put the coil. I have shown you the simulation. Yeah, false. Sir, bulb glows now. I will show you. I will show you guys. Don't worry. Watch out this. Watch out this. Okay, I have took one more simulation for you. You can easily watch it out. You can see that when I bring my magnet, if I keep my magnet like this, see, I bring my magnet, I just keep my magnet like this. None of the current is inducing. Does the bulb is glowing if I'm keeping my magnet near the coil? Tell me, yes or no? Tell me, yes or no? Tell me right now. If I'm keeping my magnet nearby the coil, is the magnet is glowing? No. Sorry, not my bulb is not glowing. The reason is that it is not been said by the scientists. Scientists said that the magnet or there should be some change in flux. That is the basic understanding. There should be some change in flux. So over here we are trying to change flux like this. See, watch it out. So I hope now you got an idea about that why the answer is false. Right? Read the question again. You can easily make the understanding. Faraday first experiment showed that keeping a magnet close to a coil will induce current in the coil. False. The correct answer is false. It is wrong. The correct answer for this is not keeping the coil near to a magnet. You should have motion. Right? What is missing over here, guys? What is missing over here? Instead of keeping, if they have written motion, motion of a magnet near a coil is going to give you induced current. But if there is no motion, don't expect any kind of induced current. Okay, it is really mandatory, guys. There must be change in flux. Yeah, very good. So for EMF, there must be change in flux. Change in flux can be caused caused due to different things, guys. This change in flux can be caused due to different things. The one of the important thing that is generally used in this chapter. Yeah. So how you can move this? Suppose I want to move this object. How can I move this object? Tell me. I want to move this. How, either I give some force or I tell this whole system only to move. Right. Something I need to do, right, in order to move this object. Right. So in order to change the flux, you can either take the help of motion. That is just now you are saying that when I'm trying to move the bar magnet from the coil, I'm using the ability of motion. Either you use motion. Is there any other thing that you can use in order to change flux? Tell me, guys. Other than motion, is there any other thing to change flux? Tell me. Other than motion, is there anything to change flux? Yes, we have, guys. See the definition of flux. Last class, we have learned about flux and its formula. We have solved one small numerical also based on that formula. We got to know the flux formula is nothing but B dot A. So in order to change flux, I can change either magnetic field or either area. Either magnetic field or either area. Either you change magnetic field, flux is gonna change, or you change area, flux is gonna change. Are you understanding the concept? Are you understanding? So it is not key only motion is gonna produce flux or only motion is gonna change the flux. Either you change magnetic field, flux is gonna change, or you change area, flux is gonna change, because you can say flux is directly dependent on magnetic field and area vector. Right, students? Is it clear to each and every of you? This is the basic understanding. So those students who have watched yesterday's class, they can understand it very comfortably and learn from their mistakes. Is it clear, guys? What actually this chapter want to say to you? This chapter does not want to say to you that if you keep the magnet near a coil, all the electricity will produce. No, you need to have some kind of motion. Why motion is required? Either motion is required due to change in flux, or you can change in flux either by changing in magnetic field or by changing in area. So that is the reason I think so. Last class we took one small example in which the ring was shrinking, right? So we have got the rate dr by dt, right? So in that the area is changing, right? You can assume it is shrinking, that means area is changing. So this is the first recall test question, guys. Let us move to next recall test question. Try to have a good approach. Don't worry if you're giving wrong answer, just at least try to participate. Okay, so this question I want your answer in the chat. Magnetic flux through a given surface area is given by express. I think so I only wrote the answer for you guys, right? But I want an integral answer. I only wrote an answer for you, but I want an integral answer. Can you give me an integral answer for this? It will be very good if you can participate in giving answer. Utilize students, please try to participate. I will wait for 30 seconds for you guys. Utilize students, I'll wait for 1 minute. I want you to participate and get me the answer. Can you please try, guys? I want integral answer, guys. How can you write in integral format? Very easy, right? So see, when I'm speaking of integral, so first of all, your formula look like this, right? How is formula? Your formula look like flux is equal to B dot A, right? It is just normally looking like electric field formula flux, or it is just looking like, suppose velocity is equal to displacement by time. So displacement can be written as velocity multiplied by. Does phi is equal to B dot A look like displacement is equal to velocity dot time? Tell me. They are just looking like same, right? So how we used to write displacement integral of displacement I can write is nothing but integral of v dot dt. The time will become dt because it is nothing but integration. It is coming in integration. Similarly, if I'm going to write integral of d phi represents smaller flux, is equal to nothing but what you can write integration of b dot ba. Is it clear, guys? Is it clear? Can you see the integral formula? I hope you can I understand and visualize these things. Right, students? Is it clear? Okay. So I'll be not teaching you today a lot of very internal things, but I'll just clearing your basic concepts, understanding this Faraday's. Okay, so that no, you should not feel difficult. So number of magnetic field lines. Yeah, that is what we are writing B. Okay. So how much is the magnetic field? We are writing that as B. Okay, so you can easily use this kind of formula either in form of integration, or even you can use this formula in kind of differentiation. If you want to find area, you can write area can be written as phi by B, right? Area vector can be written as phi by B. You can see. So you can go in a different format. So generally the answer will be this. Integral d phi is equal to nothing but integral b dot dA. The area vector have become dA vector. Is it clear, right? I hope it is clear to each and every one of you guys. We can proceed to next recall test question. This was such an easy question. We can move to next. Tell me the answer for this. This is a conceptual question, guys, and this is where you need to clear your concept. In a Faraday experiment, when a magnet is brought nearer to the coil, the force exerted by the coil having induced EMF onto the moving magnet would be attractive or repulsive. They're saying, suppose if there is some kind of coil, suppose I'm having a coil. Okay, students, this is my coil. Okay, and I'm trying to bring a magnet. So this is my north pole, this is my south pole. I'm trying to bring a magnet with some velocity, suppose V. Okay, when a magnet is bring closer to the coil, so that means this magnet, north pole and south pole, are bringing closer to the coil. So the force exerted on the coil. So this coil is going to exert some kind of force. Why it is going to exert some kind of force? Because both. How it can be both? No, guys, that's wrong. It can't be both, right? You can say directly it can't be both. Why the reason can't be both? First of all, I only one student have said me the answer. Other students, guys, good Nandis. Other student, Chetna, wrong answer. So tell me whether it should be whether it should be attraction or whether it should be repulsion. So they want that magnet is moving closer. So magnet is coming closer to this coil, right? And having induced EMF in the moving magnet. So first of all, guys, why it is very mandatory to understand this? Because you all guys could get lots of confusion over here. Okay. Okay. So let me just put it. Let me just put in front of. Okay. In order to find the force exerted, or in order to find that which is like how to get the idea that whether it will be falling as attraction or whether it will be falling as repulsion. This whole thing have been provided by Lenz law. I hope you guys have learned Lenz law in your class 9th or class 10th. Right, students? You have seen the Lenz law in which the scientist was used to put a coil and he used to bring the magnet and he used to say that magnet will act like a north pole if you used to bring closer. Okay, and he used to also say that if you're gonna bring away from it, magnet is gonna act opposite, right? So I will teach you today this is one of the question basically which I'm going to teach you. I just want to know that whether you guys can try to recall these things from your previous ninth class, because you have learned this thing in class 9, like Lenz law you have learned earlier. I know, right? So Lenz law says that when you're going to bring the magnet nearby a coil, it is going to produce induced EMF. But what would be the direction? So first of all, instead of thinking of direction, let me tell you that if you're going to bring the north pole over here, what is going to happen? Can anyone tell me? The coil is going to act like, because I am not getting any kind of answer which is related with this, what I'm expecting. So Hema, like your answer is totally a bit in different way. As far as correct answer, but I want explanation, guys. Nandis, that is not like that we are pushing. Not like that, Nandis. No, no. So exactly what is happening, let me show you a picture. Okay, let me show you a picture, then you will be very much comfortable. In order to understand this, you need to understand one factor. Okay, you need to understand one factor. The factor is, if you have, if you have, if you are talking about North Pole, if you are talking about North Pole, the current will be induced in. So if you want to write it down, guys. This is just a structure that I'm giving you today. I won't be teaching you a lot of things today because you guys are having unit test. I don't want to disturb a lot of you, right? But I want you to understand also because you feel good, right? So if I'm talking about North Pole always means you should go in anti-clockwise direction. And if you're talking about South Pole means you are going in clockwise direction. Okay, South Pole means clock. This is just a trick. This is just a trick to solve lots of questions. Okay, this is just a trick. Don't expect this that there is a derivation for this. Why we are taking? This is just a trick that we are using. For North Pole, we used to take anti-clockwise direction. For South Pole, this is we take the clockwise direction. Now let me give you an overview. Okay, so what exactly are the, my whole experiment is, I'm having a coil. I'm having a coil, and this coil. So can you able to visualize the coil in 3D? Let me show you. So suppose this is my coil, guys. I hope you can able to see. Right, this is my coil. So you can see in 3D, if coil is something like this, there will be two faces, one from this end and one from this end, right? So if I'm trying to make a coil something like this, students, there will be two faces of the coil. One from this side, this is one of the face, right? This end face, and other from this end face. There are two faces. Can you able to visualize this? Tell me, students. Can you able to visualize this? Please let me know in the chat. Guys, I want to know whether you are thinking about it or not. If you are talking about a coil, you are having two faces, one from this end, one from this end. If you're keeping the coil like this, you are also again having two faces, one from the front view, one from the back view. So you guys are always having two faces, guys, for a coil, whichever side you are saying. I will just remove that blur, okay, for your sake of reference. I'll remove that blur for some time. Just a minute. Okay, fine. All right. Okay, so I hope now you can able to see, right? So you can see that when you see like this, it is very normal to understand, guys. From copy also I can make you understand. Okay, so suppose this is my notebook, right? So this notebook is just like a some normal coil. Okay, so how can you visualize coil, guys? I have few things actually for you. Yeah, I can make you understand. So this is how a coil look like, right? So if you see from the front part, so this is my coil, guys. I hope you can see coil. This is from the front part. So from front part, you can see this face and you can see this face. And if I keep my coil like this, you can see from here, this is my front face and this is my back face, like that. So you can say like that every coil will be having some kind of faces, right? So similarly in this situation, what is happening? I hope now you can able to visualize, right? So in this situation, what is happening? Two sides, right? Right, good. So in this situation, I'm having two phases. Now what I'm trying to bring is I'm trying to bring a magnet. So guys, in this question, they have not clearly mentioned that whether you are gonna bringing north pole of the magnet or south pole of the magnet. So let us assume that this is my magnet, this is my north pole, this is my south pole, and it is moving with some velocity v. Okay, let us assume that it is going this kind of velocity v. So if it is going with some amount of velocity v, okay, so what exactly is the basic idea how you can find the direction? So if magnet is passing from here, tell me students, will this magnet will be having any kind of magnetic field? This magnet, this north pole south magnet, this will be having any kind of magnetic field? Tell me guys. This magnet will be having magnetic field lines, right students? So I can show you like this. So this magnetic field line will be this magnet will be having some kind of magnetic field line, something like this, right? Something like this it will be coming. So when it is gonna pass from this, when it is gonna move from this coil, is the flux is gonna change or not? Tell me. So as you can say that when magnet is far from here, suppose when magnet is 5 meters from here, you can say the magnetic field line strength is less. When magnet is close to here, the magnetic field line strength is more. So you can easily say that in the flux formula B dot A, you can see that the magnetic field vector direction is changing, right? The number of magnetic field lines are changing because we are bringing the magnet near the coil. So if it is changing, so is it increasing or is it decreasing, guys? Tell me. If you are trying to bring the north pole of the magnet towards here, are you increasing or are you decreasing? So this is the first and the most important point that you need to understand and you need to find for solving the direction, right? I can see that most of the students are giving me correct answer. That is, when you are trying to when we are trying to move closer, the flux is increasing. What is increasing? The flux is increasing, right students? And I hope everyone is comfortable to understand why flux is increasing. So write it down. So flux is increasing. Now second step come is nothing but due to this flux, what will happen? What Faraday have solved. Due to this flux, what will happen, guys? If flux is increasing, I got to know that flux will be increasing. Due to this flux, what will happen? EMF will generate. According to Faraday, he told that due to this flux, the EMF will be generated. Right? The formula is nothing but E is equal to d phi by dt. EMF is generated. So due to this flux, the EMF will be generated. So due to this flux, there will be some kind of EMF generated over, right? So this EMF will be in the form of current, right? Which we can see over here. So how can I say that which kind of EMF will be generated? In order to say that what is the direction of current over here, we say that if the flux is increasing, the EMF will generate such like that it will try to decrease the flux. Okay. So EMF, if flux is increasing, then EMF will generate I will try to give a proper name for this, don't worry. EMF will generate to oppose the flux, to oppose the cause of flux, to oppose OPPOSE, to oppose cause of flux. Cause of. So guys, this is a very interesting word and understand it, write it down. If you're not understanding it, write it again, understand the word, what exactly I'm trying to speak. Okay. First of all, you got to know that flux is increasing because you are trying to bring the magnet near the coil. If you're trying to bring the magnet near the coil, flux will be increasing, EMF will be generated. So EMF will be generated in which way? EMF will be generated to, EMF will be generated to oppose the cause of flux, to oppose the cause of flux. So who is producing flux, guys? Who is producing flux? Tell me. The magnetic field lines is producing flux over here, right? The magnetic field lines are producing flux over here. So what he wants that EMF will be generated to oppose the flux. So if I want to oppose this flux, what I will do? Tell me. I want to oppose this flux. I don't want that the flux should increase. What I should do? Shall I say that this face of the coil will act like a north pole and the opposite side of the coil will act like a south pole? Can I say like that? Because north pole and north pole are going to repel. And if they are going to repel, he's going to tell that move away. Can you able to connect the dots, guys? Don't worry, I have took 5 to 10 examples for you in order to understand this, the direction, because very mandatory and very important point. Okay. So what is happening? So that's why the correct answer for this is nothing but repulsion, right? So what will happen? So guys, you can see it is such a conceptual question. repulsion take place. So you got an idea that what is happening, repulsion take place. And if you are saying about north, guys, if you are speaking from north, so north means what? Tell me. North means what, students? I told you that think north as anti-clockwise. So anti-clockwise direction means you need to think in anti-clockwise direction, right? So you can say that the direction of current will be in which direction? Is it anti-clockwise or clockwise? So if you see from this end, if you see from the right hand side end, you will find that it will be in anti-clockwise direction. But if you see from the right hand side, it will find that this is nothing but clockwise direction. Sir, what causes the pole in coil? What causes the pole in coil? The EMF, change in flux. Nandis, change in flux causes the poles in coil. That change in flux is helping him to produce nothing but the different kinds of pole in coil. It is just an experiment which has been seen. Got it, Nandis? So when you try to bring, so I'll elaborate it, don't worry, after making you understand Faraday's law. Is this understandable, guys? Have you got little bit idea about this? If you have not got, no problem. We will talk later, today only, don't worry. Okay, so let us move ahead, guys, and try to understand this using the concept of Faraday's law. So in Faraday's law, I have taught you in last class that first law say that whenever there is a magnetic flux with circuit change, the EMF will be produced. That means you want to say with circuit change means there should be some kind of motion. There should be some kind of motion. And whenever there is magnetic flux, so he says that flux is nothing but whenever there is magnetic flux change, that means change in flux. Change in flux is gonna give you what? Is gonna give you EMF. In first law, he said that. In second law, he made us introduce that how much is the value for EMF. So he told that EMF value will be equal to d phi by dt. Guys, there is more elaborate formulas. I'm not teaching you today. Obviously, I'll be teaching you after unit test. Don't worry. Okay, but you should have a basic idea about few smaller formulas. Okay. So I can say that E is equal to d phi by dt. So what we can write down over here, guys, yeah, just a minute. Okay. So what we can write down over here, very good. Okay, guys. Yeah. So this is the two laws that has been given by Faraday, right? So I hope everyone have understood regarding these two laws, right? So as we have seen the experiment, when we try to move, just a minute, so when we try to move, there is some change in electrons. There is some change in electrons, right? So you can say when I'm trying to bring my south pole. So what is happening, guys? So when I'm trying to bring my south pole, so let me show you using the experiment. You will be very comfortable to understand it. So I have a coil, guys. Okay, I'm giving you different examples. Please understand it using different examples. Don't worry if you cannot understand using one example. There will be different example which will be helping you to understand. Okay, so suppose if you are having a coil, guys, you are having nothing but a coil, and you are trying to bring the magnets. You are trying to bring what? You are trying to bring magnets. Sir, increase the number of loops. Why one? Can take maximum 3 loops. They have designed like that. So you are bringing south pole, you are bringing north pole, and you are bringing south pole with some velocity. Okay. So what will happen, guys? Tell me what will happen if you are bringing south pole. So this face. So there are two faces, guys. I will say left face and right face. Okay. So this is my right face, and the back end is my left face. So tell me the right face of the add voltmeter. No, not required actually. Okay. Tell me the right face of the coil. So right face of the coil, that means this face of the coil, what it will produce? What it will produce? Tell me, guys, what it will produce, students? Tell me. Please try to participate and tell me, guys. And these other students. So if I'm gonna bring the what is going to produce? Is north is going to produce or south is going to EMF? I know EMF is going to produce. I know, Sachin. I know about EMF, but I am asking you about the north and south. I'm not asking you about EMF because I know you guys know the concept that if you're going to give some motion to a magnetic field, there will be change in flux. Since there will be change in flux, EMF will be produced. Fine, but in EMF, whether south pole is going to produce or north pole. So how you can visualize this? First of all, in order to visualize this, first of all, see, you are having which pole? South pole. So south want to go nearby. If south want to go nearby, is the flux is increasing or flux is decreasing? Tell me. If south want to go nearby, is the flux is increasing or flux is decreasing? Tell me. No one should have confusion because you are trying to move the magnet towards closer to it. Obviously, flux is gonna increase. So you're gonna say flux is gonna increase. flux is gonna increase. So what EMF will do? EMF will try to do opposite of this flux. Okay, what is the work of EMF? Let me tell you. EMF will try to do what? I'm really sorry. EMF will try to do opposite of this flux. EMF will try to go opposite of flux. So what EMF will try to do? Tell me. The EMF will try to reduce the flux. EMF will try to reduce the flux. So how to reduce the flux? That means I don't want, in order to reduce the flux, I don't want my magnet should go near to the coil. I want my magnet should be away from the coil. How can I make my magnet away from the coil? In order to make my magnet away from the coil, I need to take this part as south pole only, right? I need to take this path at south pole only. Then only they are gonna repel. Are you understanding, guys? Is this easy to understand, guys? Is this easy and comfortable? Please have a confidence. Don't worry. Do revision. Don't think like that. Ki today I have understood, after 10 days again I'm gonna sit and see the things I'm gonna understand. No, it is not gonna happen. You have to do a constant revision in middle, because these are some kind of tricks and concept that is there in books, and you have to learn it. I'm teaching you, right? So that is why I am teaching you, right, students, so that you learn in a better way. So you can see that in order to find, so guys, if it's south, so tell me the direction. Clockwise or anti-clockwise? For south, whether it should be clockwise or anti-clockwise? For south, we should take clockwise direction or anti-clockwise. So for south, you should take clockwise. So clockwise means I should move like this. That means the direction of current in this, you can even give the direction of current. The direction of current in this will be in this direction. Is it very easy to understand and clear to each and every one of you? Please let me know. Is it very easy to understand? So let us see that whether current is moving in this direction or not. So what I'm doing is I just folded my magnet. Just a minute. I just folded my magnet and I'm trying to bring my magnet nearby. So you can see that the electrons are going down, right? You can see the electrons are going down. So electrons are going down in this direction. Tell me. So if I'm trying, again, I'm trying to show you. So if I'm trying to bring my magnet, you can see that electrons are going down in downward direction. So if electrons are going down in downward direction, electrons are going down in this direction. Watch it out carefully. Electrons are going down in downward direction. So current will be opposite direction, right? The current will be in opposite direction. And these all things are conceptual, guys. If you think like you are gonna remember one thing and you're gonna solve everything, no. You need to understand the basics over here. You can very easily understand that whatever is the direction of electron, the current move in opposite direction of electron. You have learned this, right, students? So whatever is the direction of electron moves, the current moves opposite to the direction of electron, right? Yeah, current opposite the direction of electron. So when you, I'm gonna move this south pole over here, I can see that electrons are going down. Electrons are going down. Can you able to visualize and see electrons are going down? So if electrons are going down, obviously the current will be going in upward direction. The induced EMF direction will be in upward direction. Is it clear to understand the induced EMF direction from basics, guys? I'll show you a few more things. Okay, I'll just try to keep it more interesting so that you can understand. So this is one of the property that you need to keep in mind. Okay. This is one of the property you need to find. The direction, if you want to write it down, write it down. Direction of induced EMF is always such that it opposes the cause of producing it. So cause of producing it is generally flux only, right? It's generally flux. Cause of producing is generally flux. Most of the time flux produced, right? EMF is produced by flux. That is what I have learned, and that is what we have learned till now, right? And it has been given by Faraday. Yeah, good Nandis. That is very good. That will be opposite. Okay, so let me show you some of the examples. So tell me, suppose this is nothing but my circular coil. Okay, students, this is my circular coil, and I have a already magnetic field present over here. This is my external magnetic field, which is already present over here, right? So the direction of magnetic field is towards inwards. The direction of magnetic field is towards inwards. So if the direction of sir, let me write. Okay, fine. Direction of magnetic field is towards. Write it down. I'll give you 1 minute. Okay, I'll just make it over here. Okay. So what I'm having a coil, and the direction of magnetic field is towards inwards. Okay, students. So tell me that which direction should the induced EMF should be generated? Can you tell me which direction the induced EMF should be generated? See, magnetic field is already inside. We are having a coil. So flux will be produced, right? what will happen? Flux will be produced. So instead of saying south and north, guys, don't always say south and north. South and north are just the techniques that I taught you. Okay, in examination, you are not gonna leave like south or north. You should understand with the direction of clockwise and anti-clockwise. So Soumya have told me that, sir, it will go anti-clockwise, right? So how can I visualize this? So you can see that the magnetic field lines are inwards, right? So due to these inward magnetic field lines, what is happening? Tell me. Due to, so I'm just writing it down step by step procedure. Due to this inward, due to this inward magnetic field line, what is happening? Due to this inward magnetic field line, what is happening? Tell me. What is happening, guys? Tell me, please. I know you guys know the answer. Students, due to this inward magnetic field, what is happening? Due to this inward magnetic field, flux is changing. Flux is changing. Am I right? You should have an idea, guys. Even though you know the word flux, but you don't know how to use it, then it will be very bad. Okay? You know the word flux, but you don't know how to use it. Okay? So please keep these things, keep these points in mind. These are very smaller things. Is it clear, Nandi, Soumya, Hema, Aswini? Guys, is it clear? So due to the inward magnetic field, what will happen? Flux will change. Okay, if flux will change, I can say that flux is gonna change. So if it is gonna increase, if flux is gonna increase, what you gonna say? If flux is gonna increase, if flux is gonna increase, so I can say like that. See, so I need to oppose the motion, right? So you know the flux is changing due to magnetic field. So phi is equal to B dot A. So due to the area and the magnetic field is inside. So what should you do? You should oppose it. You should oppose it. So the direction of induced EMF such that it should oppose the cause of producing. So here magnetic field is cause. What is cause, guys? My cause is magnetic field. So magnetic field is helping me to produce the induced EMF. So how can I oppose this, guys? Which direction I should place my current so that magnetic field will be opposed? So you can say that if you're going to curl the finger in the direction of uh, current. So if I'm going to put the direction of thumb, sorry, I'm really sorry. If you're going to put the thumb in the direction of current. So if I put my, so you can take both the cases. There will be either clockwise or anti-clockwise. First, let me take the case of anti-clockwise. So if I'm taking the case of anti-clockwise, that means my direction should be like that, right? So according to this, if I'm keeping my direction like this, I'm getting the magnetic field that is outwards. I'm getting a magnetic field lines that will be outwards over here. Whether this outward magnetic field lines will help to reduce this inward magnetic field lines. Yes or no? Think and tell. Whether this outward magnetic field line, students, is going to help the inward magnetic field lines to say yes or no, guys? Yes, it is going to help, right? So the correct answer for this is nothing but anti-clockwise only. Anti-clockwise only. What if you take clockwise, guys? Right? What if you have done mistake and you have take clockwise? See, if you have took the answer in clockwise, see. So you put your thumb direction in the direction of current. You're gonna find that over here the field lines are, so over here in the center, the magnetic field lines are coming inside. So is this increasing the flux or is this decreasing the flux? If number of magnetic field lines are increasing over here due to the current, whether it is increasing or whether it's decreasing. So you're gonna say that flux is increasing, flux is gonna change. Hema, so flux is gonna change. Even in clockwise direction also, flux is gonna change, guys. Okay, flux is gonna change because you can see current direction is in this direction. If you're gonna curl the finger, you're gonna say that the finger is pointing inwards. But what is happening? This is not the cause, right? It is not going opposite of its cause. So as per the understanding, the direction of induced EMF is always such that it opposes the cause of producing it. So previously the flux was producing due to the magnetic field line. I want to oppose that magnetic field line. I want to go opposite of that magnetic field line. So in which direction I should flow my current? So if I flow my current in anti-clockwise, I got to know that my magnetic field lines will be towards outside. You can use this concept also, guys. Curl a finger in the direction of magnetic field line. Thumb is gonna give you the direction of magnetic field line, right? So you're gonna see that curling the finger in the direction of current. If my current is in this direction, the magnetic field line will be outside and it is gonna oppose it because previously the magnetic field lines are going inside. Now it is opposing. So that's why the direction of magnetic field lines are nothing but opposite. Is it clear, guys? Is this example is clear to each and every one of you? Just let me know. Is this example is clear to each and every one of you? Just let me know, guys. I have took another example. Okay, I have took one more example. Can you tell me? So over here, I'm having nothing but I'm having I'm having a square box, right? I'm having a square box. Everyone can see. And this square wire is having nothing but it is having some kind of magnetic field over here. It is having some kind of magnetic field lines over here that is outwards. So these magnetic field lines are outwards. So according to the diagram, you got to know that magnetic field lines are outwards. So due to these magnetic field lines, what is going to happen? Flux is going to produce, right? Flux is going to produce. So flux is going to produce over here. If flux is going to produce, in which direction? So let me say that if flux is increasing, so in which direction I should move my current so that it should oppose it. So shall I move it in clockwise or shall I move it in anti-clockwise? So what if I go wrong, guys? If I move it in anti-clockwise, okay, let me first move it in anti-clockwise. What will happen? Let me tell you. If you move it in anti-clockwise, you can see that if I'm gonna move in anti-clockwise, the flux that you are trying to get is the magnetic field lines that you will be getting is in upward direction only, that is outward direction. So that so basically your magnetic field, your flux is outwards. Your flux is outwards. Okay, your flux is outwards, right? Your flux is outwards. You want to oppose this. What you want to do? You want to oppose it. Oppose to get what? To get EMF. Why I want to oppose? I want to oppose to get EMF. That is a conceptual understanding, right? To get EMF. So if I want to oppose this, if I move my current in anti-clockwise direction, I will get the magnetic field in the same direction of flux. So I don't want to do that. I want to oppose it, right? I will go opposite of that. Are you understanding the concept, guys? I hope this is very comfortable to understand. For few students, it can be difficult also, guys. So that's why I took lots of example to make you understand. So the correct direction for magnetic field lines will be direction of induced EMF will be in this direction. So induced EMF or induced current will be flowing in this direction such that the magnetic field lines will be coming inwards and it is trying to oppose the outward magnetic field lines which is already present over there. Right, students? Okay. So let me show you a very different case scenario so that you should not feel difficulty. Okay, so we have two cases, guys. This is my first case and this is my second case. I will talk about both the case one by one. So let us talk about first case. So if I'm talking about first case, my first case, what is the scene that they have given? I am having a coil. I am having a coil that is of circular in shape and I'm also having a wire. Okay, this wire is having nothing but current as I and it is in increasing. Okay, that means current is increasing. If current is increasing, what do you mean by current increasing, guys? Obviously, if current is increasing, you can say that magnetic field is also going to increase, right? If current is increasing, magnetic field lines is also going to increase. So, what is the kind of magnetic field lines it will produce? So, you can see putting your thumb in the direction of current, you're going to find the magnetic field lines will be coming outside. So, you're going to find that whatever is the magnetic field lines that is drawn over here, it is going to come outside, right? Now, if the magnetic field lines will be coming outside, then in which direction in this coil the current should move so that it should oppose this outside now. So magnetic field lines are coming outside. I want to oppose it, right? I want to oppose it, right, friends? So if I want to oppose it, you can say that flux is increasing. If B is increasing, you can say flux is. I want to decrease this flux. That means I want to oppose this. Flux is increasing. Okay, I'm just writing it down in a very clear picture, guys, so that no one should have any kind of confusion. So should I move in clockwise or anti-clockwise? Very good, Nandis, clockwise. So you have to move in clockwise direction, right? Because what will happen if you're gonna move in clockwise direction, the magnetic field lines will be towards inwards and it is gonna oppose this outward magnetic field lines that we don't want, right? Is it clear, guys? Is it clear? I will write it down. So flux is increasing. That is the reason. If you want to, you have to oppose this. You have to oppose this to get what? To get EMF. To get EMF, right? To get the EMF structure. Second case also anti-clockwise. Yeah. Correct. So you have to do what? You have to get the structure. So what you need to do is you need to oppose this, guys. Opposition is a big word. Okay. I want to show you the meaning of opposition. Here, what was happening? Here, my magnetic flux was increasing because my current was increasing. So if my current is increasing, my magnetic flux was decreasing. Increasing to get EMF value, I need to decrease my magnet. I need to oppose it. If flux is increasing, I need to decrease my magnetic flux. Right. So you can see that they have written decreasing. Right. Now, in the second case, you will find out again, I am having a coil. Okay, and I'm having a wire, and in this wire the current is going in downward direction and it is decreasing. The current is what is happening to current, guys? The current is decreasing. So if my current is decreasing, I can find out that whatever the magnetic field line that is present over here will be inward direction, right? Not due to decreasing, because due to it is going downward, right? So magnetic field line will be in inward direction. So if magnetic field lines are inward direction and magnetic, so what is happening to flux? Is my flux is increasing or my flux is decreasing, guys? Tell me. So you know that your magnetic field is directly proportional to current as well as area also. Okay, your magnetic field is directly proportional to current as well as area also. Right, guys? The distance means from where it has been kept. Right. So I can say that my magnetic field lines will be decreasing. So if magnetic field lines will decreasing, I can say my flux will be decreasing. I'm just trying to correlate the things, guys. I'm trying to show you. My flux will be decreasing. Right, students? My flux will be decreasing. If my flux will be decreasing, what I need to do? Do I need to decrease my flux more? No, I want to oppose it. What I want to do? I want to oppose the flux. Whatever that is happening with the flux, I want to oppose it. Why I am opposing is to get the value for EMF. Guys, this is a technique to solve questions in an easy way. To get the value for EMF, right? So EMF value will be this direction. So if all the magnetic field lines are coming outside, I want magnetic field lines to be sorry, all the magnetic field lines are coming inside. I want magnetic field lines to be coming outside. So if I put in anti-clockwise direction, I will get that the magnetic field lines will be in clockwise direction or anti-clockwise direction. So do I need to put all the fields in clockwise direction or anti-clockwise direction? Tell me, guys. Which is the correct answer? Is clockwise direction is the correct answer or is anti-clockwise direction is the correct answer? Tell me, students. Here is the confusion coming into picture. That is why I gave you this example. So most of the students will say that, sir, because electric field lines are coming inward, so I want to oppose that electric field lines. No, don't do like that. Okay, understand from the logic. You need to oppose the cows. You need to oppose the cows. So you can say that cows is due to the flux, and flux is decreasing. So if I want to oppose it, that means I need to increase my flux. I need to oppose it, right? Decreasing opposition is increasing only, guys. I want to increase the flux. So how to increase the flux? Can I increase the flux? Normally, no. If I want to increase the flux, I need to move my finger in, and my net magnetic field should be in the direction of flux only, right? In the direction of magnetic field. That is the reason I am moving it in anti-clockwise direction. So if I move in anti-clockwise direction, what will happen, student, is nothing but, sorry, if I move in clockwise direction, I'm really sorry, not anti-clockwise direction. If I move in clockwise direction, what will happen is nothing but all the magnetic field lines are gonna come inside only. And if magnetic field lines get inside, what will happen? They will add up and it will increase. I want the mag flux value should increase. Is it clear to each and every one of you? The correct answer for this, not anti-clockwise, it is clockwise, guys. Not anti-clockwise. This is clockwise direction, right? As far I know, the clock moves like this. The correct answer for this is not anti-clockwise, it is clockwise. Is this understandable, Nandi, Soumya, Kishore? Can you able to see the difference between these two structures? In first structure, the current was increasing. In second structure, the current was decreasing. Since the current is decreasing, the flux is decreasing. And I don't want the flux to be decreased. I want the opposition. So opposition, in order to have opposition, the flux will increase. And in order to have increase the flux, the current will produce in the anti-clockwise direction. Is it clear to each and every one of you? Soumya, Kishore, please reply me in the chat. Other students also, please reply me in the chat. So I will not go deeper. Don't worry, guys. Just have an idea that are you guys understanding it? Very good, very good. So practice, guys, practice. Don't always think that whichever is the direction of current, I need to take opposite of it. No, it also depends upon the case and scenarios where current is different. Okay. Okay. So if this is clear, guys, I'm just going to put one more point in front of you. So what will happen if I'm having a wire? Okay, this wire is having some kind of current and it is producing inwards magnetic field over here, right? And I'm having a coil also, guys. I'm having a coil, but this coil is not getting far away. This coil is here only. This coil is here only, but it is moving in this direction. The coil is moving in this direction with some velocity v, right? So what can I say? What will be my induced EMF? What can I say about my induced EMF, guys? Can you tell me? Can you tell me and get me the answer? What will be the induced EMF? As you can say that what is happening over here, my current is constant, my current is not changing, right? As well as my magnetic field is also constant, right? Magnetic field is also not changing, even though the area or the distance from where it is been kept is also constant. It is also not changing. So I can say my flux will be nothing but constant. If my flux is constant, what do I want to do? I want to do opposition of this, right? So I cannot make my flux as variable. So what will happen? I cannot, if it is constant value, what will happen outwards? Instead of saying outwards, I told you that give me answer in clockwise or anti-clockwise. That is far better. Means instead of giving me answer in outwards, inwards, that is not a good scene. Means that is not a good way to represent a answer. Okay, so get me the answer in like that format. Whether it is clockwise. Okay, current producing due to the flux pattern. Okay, fine. Any other answers, guys? Any other answers? Just let me know. Any other answers, students? Okay, Jagan is saying anti-clockwise. So is saying clockwise. So is this confused? Is this isn't confusion? Is this confusing? I don't think so. Anti-clockwise. North Pole. This how can it be North Pole? No, no, no. That means you have not understood it. See, both the terms will be constant. Obviously, there will be no induced EMF. Explain it once again, sir. Yeah, Jagan, I'm explaining it once again. As you can say that yeah, normally how this, first of all, when you try to find over here, see the flux is not changing, the area is not changing. If there is no change in flux, what will happen? Tell me, guys, if there is no change in flux, flux is constant, no change in flux. Huh, very easy, right? Was it too tough, Jagan? Other students, guys, if flux does not changes, no EMF. You're gonna say the current over here will be nothing but whichever direction you say, it will be zero. It will be zero. There will be no EMF. Yeah, no EMF. I told you. Okay, good, Nandis. Very good. If you have said, then it is very good. I want to just check. That is the reason I told you that give me the answer in anti-clockwise or clockwise. Because most of the students have just thought that, oh my God, answer will be in anti-clockwise and clockwise. They have not thought that if current is constant, the area is also not changing and it is also moving some velocity. Velocity is there, but flux is not changing because neither it is going forward, neither it is going inward. So in these case scenarios, what was happening? Either it is going forward or it is going inward, right? No problem, Jagan. Okay, is this understandable now, Jagan? Flux does not change. If flux does not change, there will be no EMF. Okay, good, good. So these are some basic understanding you should have with respect to the direction of EMF. Right? Okay, so I hope you guys have got little bit idea about direction of EMF. So I am not going too much deeper. If you have any kind of doubt, please ask me. And I want to know, guys, what is coming in your unit test. So I got to know that in your unit test, the chapters that is coming is electrostatics, right? Electrostatics. Okay. The second chapter that is coming in this is nothing but your yeah 1 and 2 capacitor. Okay. Or electricity chapter. Okay. So tomorrow what I will do, guys, I don't think so. Tomorrow I will let you know about tomorrow what is the schedule. Okay. So we will try. I will try to make you understand just a revision from NCRT. Will be helpful for you for your unit test? Tell me, students. A revision or our understanding of few concepts from NCRT, will be helpful for you, guys? Means I just want to help you in this case. So I want how can we utilize the future 2 to 3 days so that uh, we can use it. Exam is scheduled at 3 to 4:30. We will try to manage. Okay, second exam. Yes. Okay. Okay, second exam is only. Okay, guys, we will see how does it goes. Okay, so we will see how does it goes, and we will go it. It will directly go, guys. Utilize students also. Please make sure that you try to solve questions. Second day, first paper is physics. Okay, got it. Okay, that's is also good. So utilize students also, and okay, Jagan, no problem. Make yourself free. We will let you know a good thing. today in evening. Don't worry, guys. Don't worry from Avanti side. They will be always cooperating you with these all things and helping you to grow. Okay, where we do some strictness, you should understand ki we are experienced person and we know things, so we can help you to pass the way, right? So we can do that tomorrow. We can have, like, if you have any kind of class, we can have a little understanding with respect to NCRT. And if you have don't know class, then you can ask me doubts of, regarding any concept. No, there will be. I have no idea about holiday. I'll let you know, Hema. I'll let you know. Just like today evenings before 8 or 9, you will get to know that whether they will be having classes tomorrow or not. Okay. So don't pre-assume from now only, guys. So guys, that's all for today, guys. I will be not taking a lot long class. You have test tomorrow. Make yourself comfortable. Any kind of doubt you can ask me. I'm just launching poll. And today, what we have learned, please make that in. Have keep in mind. Okay, because I just gave you a little idea about today regarding directions. Thank you. We'll check Nandis. How does it goes? We'll check with our schedules and we'll let you know. Okay. Thank you, guys. Make sure that you do preparation for your unit test. How much you learn from here, you can implement it over there, guys. Okay. So today we have learned about direction. In direction, we got a very important property that whatever is the direction of induced EMF, it is always such that it opposes the cause of producing it. That means if induced EMF, that is if flux is increasing in the circuit, induced EMF will be produced such that it will try to oppose it. It will try to oppose it. Thank you, Nandis. No problem. Thank you, Sachin. Bye-bye. Enjoy, guys. Enjoy means study. Don't waste your time. Okay, just because we have gave you like a few time. Okay, so make yourself confident, and if any doubt, please feel free to ask in the uh, WhatsApp, guys. Feel free to ask. So do we have class during unit UT? Pavna, I will tell you till 8 o'clock, okay, Pavna? We have meeting today, so after meeting we'll let you know. So study should be enjoyment. Yes, yes, Nandis. So no time for enjoyment, sir. No problem. You understand things, everything will be enjoyable, guys. If you understand a thing, pakka everything will be enjoyable. If you know that, oh my God, F equal to MA, there is something called F equal to MA. Don't learn it in the think of like burden. Understand it better. Okay. Thank you. Thank you, guys. Thank you. If any kind of doubt, I want utilized students also. You can ask me doubts in the Telegram group, utilized students. And none of the utilized students are talking in the chat. Why is it so, guys? May I know? Guys, why don't you chat in the like? Why don't you talk in the chat? I cannot able to have any kind of interaction with utilized students, guys. I want to have a good interaction with you also. Is there anything? In none of the students are giving answers also in utilized. Is it so? Okay, guys, then that's all for today. We'll meet you there in next class. Make yourself comfortable and feel free to ask doubts, guys. Okay. Thank you. Yeah, Nandis for NEET. Sir, for NEET, what you want, Nandis, for NEET? I didn't got you. Can ask. Physics reference is best. NCRT, go for NCRT and go for module. I'm damn sure that if you're gonna complete NCRT and module, have a good knowledge about that chapter. Okay, and then you can go for so module and NCRT is more than sufficient for a NEET. Than this, more than sufficient. Module and NEET is more than sufficient for NEET, guys. Not more than that. But for JEE, make sure that you solve module, you solve NCRT. Why I'm asking you to solve NCRT? It's gonna help you in your board exams also. You don't have to go here and there while like during board exams. I have to prepare extra for some kind of thing, right? So that how it goes when the exams comes near, right? We don't have to go like that. Else it will be burden, and we don't want. So don't worry, guys. Your whole syllabus will get over by October end. Means class 11th also, as well as class 12th. So class 12th as well as class 7th. Yeah. Yeah. So we have managed the plan like that so that it can easily get covered and you can do revision also to 2 months or might be 1.5 months will be your training sessions will be going on. Like you guys need to give tests, you can need to check might in that will happening in Novembers and Decembers. And guys, one thing I want to know, what do you guys have? Yeah, class level. Yeah. What do you guys have idea about major test? Have you guys given any kind of major test till now? I want to know, students, have you guys have participated in any kind of major test till now? Major test, not mock test. It's major test. Any major test, guys? Have you participated? Okay. So seems none of you have participated. So guys, I am planning to have a major test for you guys. Not now, might be after at the end of this month, or we will let you know 10 to 15 days earlier only. Okay, so when this major test will be happening, the meaning of this major test, actually what is happening in major test, this is a test of group of chapters, right? So first 6 chapters like that, or first 8 chapters, or suppose in class 11 we have taught you till chapter number 7 or 8 only, right? So first 7 chapter, just like a major test. So we'll try to keep and we'll let you know about such kind of decisions which is gonna happen. So make sure that you ask all of your friends to join the class. Those who are not joining class, inform them during the test time. If you're gonna meet the friends or if you're gonna have a conversation with your friend, inform them to join the class because it is free of cost. You can learn lots of things and make yourself brighter for life also. Okay, then that's all for today, guys. Thank you so much for joining my class. From tomorrow, we'll let you know that what is the schedule that is gonna follow.